Self-secondary features as analogs to self-secondary impact craters on the Moon have been identified on Earth in the volcanic terrains of Craters of the Moon National Monument and Preserve in Idaho. These features were formed from a phreatic volcanic eruption which released rock into the air on ballistic trajectories, which then re-impacted the volcanic melt sheet surrounding the Kingsville Fissure System. Although the ejecta that formed these two types of self-secondary features originated differently on the Moon and Earth, features on both planetary bodies fundamentally formed from the similar physical processes in that they were the product of ejecta fallout on a not yet solidified target immediately after the emplacement of that target material. In other words, both are self-secondary impact features. For this work, we initialized a proof of concept project to finish measuring the self-secondary features with a virtual reality environment rendered from the collected LiDAR data at the KB volcanic field. This approach will allow us to collect the necessary data to complete the science investigation at lower cost and without the associated time constraints of travel to the field. We have compared VR field measurements to in situ field measurements of feature size, distribution, morphology, and morphometry by measuring the same features in both environments, and found excellent correlation between the VR and field measurements, thereby ensuring the robustness of the proposed VR approach. In addition to completing the science investigation of the KB self-secondary features in Idaho as analogs for the lunar self-secondary features, we will also assess the VR technologies required to enable such planetary science fieldwork to be successfully conducted, as well as the operational approaches and best practices for conducting fieldwork in virtual reality. Here we have a movie showing what it looks like in the virtual reality environment and how we're taking our field measurements and comparing them to what the measurements that we took out in the Kingsville field. On the right, you'll notice a picture, and one of the first things we noticed when we rendered this terrain in the virtual reality environment was how similarly it looked to actually being out in Kingsville. A lot of the same textures that you can see out in the horizons, you can see in the virtual reality environment as well. So right now, this just showed was an example of us taking measurements, and the measurements have come really closely to what we measured out in the field, thereby proving that this is an effective way to do analog field studies of planetary surfaces.